I'm Johannes, and I'm with John Wentworth. So it seems like, as humans, we have various intuitive concepts that we apply when we see agentic systems in the world. For example, if you look at the gazelle, that's like, it has like, we might say something like, oh, it has the ability to run really fast. And what we don't observe, though, is like the gazelle that runs really fast like into a tree. This is normally not like behavior we observe. So it seems like just because you can do something, like doesn't mean that you will do it. Even if you have a system that we would say that can do something, it only uses this capability in very particular ways. And we might describe it as like, oh, the system like wants something, like the gazelle like doesn't want to run into the tree. Or you might say like, oh, the gazelle has like the goal of surviving, and therefore like it wants to run away from like lions and stuff like that. And I feel like these intuitions that we have, they point towards something in the world that's like actually important, that actually tells us something about agentic systems. And what I want to do is formulate concepts that capture these intuitions in such a way that we can apply them to computational systems in general. So here are some things that I thought about. So first, I'm going to explain things in terms of like in the ontology of like the weights of a neural network, but these concepts that I'm explaining are actually, I think, general, and they are, like, for example, we could apply them also to like the activations or like something completely different. So, and also I'm going to like assume sort of the network has a certain structure. This is like unclear right now if this sort of structure would develop in current systems. But we can imagine, for example, that like in the gazelle, we have like a certain component in like its neural network that is like sort of encoding the capability of running really fast. And we can think of this as like some computation of like neurons where we like take some input, and the input sort of like could be something like a direction to run into, some like high-level description that controls the ability. And then we have like a different thing, which is sort of like a controlling mechanism, which I would call like a modulator. So, okay, this is kind of dumb because this is supposed to be small. So imagine like we have like something that is like sort of computing something, and then feeds into the capability to like control it. And in the simplest case, this might be something like we could say like this is the ability of running away from objects that are harmful. And then this could literally just be something like description of the object, like for example, or like certain properties that we want to detect, like, oh, this looks like a line, and therefore like this, we want to get far away of this, or maybe something more complicated, like, oh, I should be afraid of this, and then somewhere downstream it results in you running away. And the thing is, what I call the modulator is like the concrete configurations, let's say in this case of like neurons, and like the computation that is performed. And there's a different concept, which I would call like the locus. And the locus is basically the box that we put in the concrete configuration of computations that we want to do. And I feel like this is like a very important difference, because if you think about like the locus, then we can ask lots of different questions that we normally wouldn't ask. For example, we can start to ask, or like first like maybe, like you can, for example, now think about like how powerful is a locus? Like how powerful is a set of parameters? Like we can think about, we have these sets of parameters, and like we don't assign values in the locus. But like for all possible like configurations of these parameters that we have inside the locus, how many different behaviors, meaningful behaviors, can we induce? And it's like if you take like the meaningful behaviors we can induce over the size of the locus, then we can get something like that I would call the power of the locus. And we could also do this like with a set of like tasks that we care about, and then like think about like how many of these tasks can we like perform well on by like finding the right modulators in the locus. Yeah, and so like this allows us like to ask various questions. For example, we can ask like, does this sort of structure even arise in like the normal like deep learning paradigms that we use today? We can like ask like how do we find these structures, if you know? How do we find these powerful loci? And like how do we understand the interface of the loci? So what I mean with that is you probably have like some specific encoding in this. Like, for example, if you in the general case, a very general example would be like, imagine this is in some sense just encoding a utility function, and this is an AGI that's structured in such a way that the system always sort of, the changes to the utility function propagate through the entire system, and it always acts as if it's optimizing this. Then we sort of can, like probably like the encoding of the utility function will be something that's kind of different from what we expect. It will not be like a simple function, but it will be like we need to like in some weird way like map what we want, the actual function that we describe in some way, to like the parameters. And like this is what I mean with like understanding the interface of this locus. Then we can also ask the question sort of, how do we like maybe set up procedures to train systems such that we get these powerful loci out as a result of the training procedures? So I think this might be useful for alignment if we can do this, because by default I would expect that these modulators and loci, they are really small compared to the actual like capabilities. Like you might have like a really complex capability. You could also think of a different example, like somebody plays like an ego shooter like Counter-Strike. Then you need to like have the ability to like move around and aim, keep track of enemies where they go. This seems like probably is very complicated computation. And then you might have some really simple computation, which is like defining, for example, like which people to shoot. And then you want to shoot like not your teammates, but like the other ones. Or you could like, if you understand the locus, you could probably like, by only looking at a very few parameters, change them in such a way that you like control what you shoot at, and then you shoot like at chickens instead of like the enemies. Yeah. So, and yes?
Can I ask a question?
Sure.
What was the exact difference between modulator and locus?
So the modulator is so I guess the modulator would be some, like imagine this is the thing that is like run away from an object. Then the modulator would be like a concrete like configuration of neurons that is like corresponding to like information about, that describes sort of like this is a lion or something like that. Or like literally it could be like this thing produces like an image of a lion, and then I'm exactly afraid if I just see exactly this image of the lion from my perceptions. Like this would be the modulator that modulates me to like be afraid of a particular thing. The locus is sort of all of these parameters that we have, and we could imagine like if this is sort of like a well-structured locus, we could imagine we just put in a different image, like we put in an image of a chicken, and then the gazelle gets afraid of chickens. And like the locus lets us like think about like this like set of parameters, and like how much can we like control the system by just changing these parameters. And the modulator is like the concrete, like any concrete set of assignments.
Is this entire thing a deep learning model, like some model basically, like a neural network?
Yes, I'm imagining this like just some neural network now.
So is this at all similar to the DeepMind's capture the flag kind of stuff, where they find here's the cluster of activations or something that like correspond to
yeah, this would be like finding the modulator. It's not clear. I also haven't read the paper, but like the thing about the modulator is just because you have like some computation corresponding to you performing well on some task, does not mean that you can use these sort of parameters to like reconfigure them to do some completely different task. Like one really good outcome about this project would be if we get something where we like find these loci, then understand them, and then we're able to sort of rewrite the behavior of the agent by like doing this. But whereas like if you just have a modulator, it doesn't mean like you can just take the parameters of the modulator and like change them to do lots of different behaviors that you care about. Yes. Okay. So
it's like fundamentally associated with that concept or idea that's supposed. Okay. Is it like that? Or?
I didn't understand that.
Sorry. So that module would like fundamentally represent that concept of being afraid from something. Is that accurate? Like you said, for
so
instance,
like the
instead of a gazelle, if I fed it an image of a rat, and it went through that, you'd say now it'd be afraid by that rat, right?
Yeah, like this is like the image of the rat, and this is like the mechanism for being afraid. Like this is their capability.
Do you expect these kind of things to be multiply expressed in a deep learning model?
I don't know what that means.
Like there'll be, maybe there's like multiple such loci or something that correspond to like slightly different use, like input cases or something.
I mean, it could be. Like, the thing is, I don't really know right now how it by default would arise. But the thing is that I think we could probably design training procedures in such a way that we get these really powerful loci that are like small, and then we can like experiment with them and like only like have like a few parameters to worry about. And that seems like to make the problem a lot easier. But now I want to like actually talk about some experimental ideas quickly. So one experimental idea to like basically induce the loci would be like if we have like a neural network, then we could basically here feed in like the goals. Like we imagine like we have like a certain task, and then we have a set of goals that we would like the network to do, and then we have like some perceptions that we also feed into the network. And what we do then is like we split sort of like this. Imagine this is a dense neural network. Then what we can do is sort of split the network in half in the sense that this selects all of the connections that go from the goals processing to the perceptions processing and from the perceptions to the goals processing. And then we just delete all of the connections from the perception processing to the goals processing, and we penalize the like information like that flows from the goals processing to the perception processing to be as small as possible. And then we would get something where like we have like some information flow that is like I would expect, I haven't run this experiment yet, that are like a few weights that are like large that like correspond to information flowing from the goals to the perceptions. And then what we can do, we can just look at like which ones are large, and then we basically have a locus. And like the idea of this project is sort of like to figure out like how does this even look like. How do these, like what sorts of information is encoded in like the things that like flow from the goals to the perceptions? Like, for example, we could like look at them, and then we could like interpolate them, and we could like also like ideally probably this should be like a continuous task, like a continuous goal specification, and then we can like figure out like, okay, we like trained like in this like we can imagine like the specification in some sort of space, a point, and then we can like think about like, okay, here's like a point that we want the agent to perform as a task that is completely outside of anything that we trained on. Can we figure out how to do this by just setting like the weights of like this information that flows over? Yeah. How much time do I have?
Yeah, I have no time left, sorry.
Okay. Yeah. Also, here's like we could not output anything, and here's the output. Okay. Yes.